and Assalamualaikum. We are from Group A. We like to present our design, which is a video scribbler. First, I would like to introduce our group members, which is me, Muhammad Idin Muhammad Nazri, and Nohidatul Izati, Muhammad Uwas Akil, and Lingeswar. Next. First, I would like to talk about the design background. First, the problem statement. The current knapsack in the market that farmers use have many problems. First is, it puts high stress on the farmer's body. Second, small tank volume for fertilizer need to be refilled. Third is short sprinkling range. And lastly, longer period of time to finish the fertigation of the field. Our objective for this design is to reduce overall farmer workload. Then we like to reduce the stress on farmer's body. Next, we would like to build a larger tank volume and increase the sprinkler range. Our target market is small scale and medium scale plantation field. We also target to rural areas. Okay, next. Okay, the technical requirement is the total weight for the product we like to build is around 300 kg to 4.5 kg. Cost required but that need to be applied by farmer is after certain calculation, we find that 339.49 Newton until 0 Newton. And the volume of the tank we set is around 100 liter to 50 liter. Sprinkler range is around 50 meter to 2 meter. Then the time required to finish fertigation is 0.5 hours to 2 hours. Okay. Next.
So the next part is design concept and design analysis. So after considering the technical requirements and problem statements, so we have decided 6 design criteria, which is the force required, total pressure on tires, volume of the tank, sprinkler range, times required to finish per row of the field, and also the correction prevention. So each of these criteria is actually created to surpass the current knapsack in the market, but not too much that it will constrain some of the features here in our design. So we have come out with 4 conceptual design, which is design A, design B, C, and D. So we further evaluated it in the concept screening. So we decided for design C, D, improve A, and also the combination of design B and D to move to the next evaluation. So this is the next candidates for the design, which is the concept C as the reference, A plus, D, and BD. So the next evaluation is through the concept scoring. So here you can see the evaluation through the calculation, and after discuss, we have choose the improve A design to be our final conceptual design. So it has the handle here with 4 big tires, the adjustable sprinkler bars, and also the plastic cover here. So next.
Okay, this is our final design. Our final design engineering drawing. And then the certain dimension. Okay, next page. This is the drawing that we made assembly by using SolidWorks program. Okay, next.
So there's 4 important parts that will be analyzed to make sure our design can be used safely. So the first one is the base chassis. So the material used is the Austenity 304 stainless steel, which allowable stress of safety factor 3, and also the yield stress here. So after being analyzed in the finite element analysis, so we get the maximum stress is the allowable stress and also the yield stress, so which means it is safe to use, and it will not have any permanent deformation. And for the total deformation here, in the second picture here, it is very too small that it almost negligible, and also concentrated on the center. So the next part is I pass to the next presenter.
Okay, thank you, Hidayah. Okay, now I'm going to explain about the analysis on the sprinkler range. So the analysis on the sprinkler range is that we find the time taken and the range. So for the time taken, we get a 0.05 million for a certain range, which is the 1.08 meter. So and if we compare the 1000 meter, the time taken for it to finish is 47 minute. So it's appear between the time required. So next is the analysis for the handle, same as we done for the base chassis. So the total deformation is 0.01465, and the equivalent stress has been stated. So next, we go for the tire analysis, which is the material for the tire is used rubber. So for that, the total deformation is 0.03405, and the stress that can handle the tire is around 11.02 megapascal. As you know, this is all under assumption, so we're not sure the original value. It will change depending on the time. Next. So next I'm going to discuss about the costing. So the costing, we divided into the certain part for each part. First, we for the tire, drive shaft, knob shaft, and sprinkler, hollow rod, base chassis, and base chassis. Base chassis divided by two for with different thickness and different dimension. Next. So next we go for the engine. Engine we use aluminum alloy so that it can be stand a longer time. So a tank, pump, pipes, rubber stopper, nozzle, connector, bearing, flat. So the total amount that we require for the material is around RM 1090. So next I go pass another next presenter. Thank you.
Okay, for the material selection, it is function as a fertilizing plant, and the objective is to minimize the mass and maximize the tank volume, and maximize the sprinkler range. And the material constraint must not easily get rusty, and must not deflect too much under design load. Next, and this is the component and material for the body part. For the body frame, we will use the stainless steel because it is lightweight and ductile. And for the cover, we will use polycarbonate plastic, which is weight much less than glass and resist shattering and breakage. And for the pipe, we will use plastic type polyethylene, which has a high impact resistance. And for the tire, we will use rubber because it is more durable uh, and more suitable for the off-road surface. And for the pump, we will use stainless steel also because it is durable to protect the pump for impact damage. And it is also lightweight and water resistant is quite high. And for the sprinkler, we will use plastic for the material. It is because it is what has a water resistant and commonly used for water sprinklers. For the engines, usually uh, engine use aluminum alloys because we want to minimize the mass. So it is suitable for our project to use aluminum alloy because it is lighter, but has higher wear properties than steel and iron. And for the water tank, we will use same as a pipe, which is polyethylene, because it is relatively light in weight and extremely durable. For the wheel, we will use PVC because it has a good mechanical strength and toughness. Next, for the feet and for the feet, for our project wheel sprinkler, we choose interference feeds and running loose feeds. For feeds, interference feed, uh, we use for the part tire hole and shaft. For the closed running feeds, we use for the knob bolt, pin and sprinkler hole and fastener. Because for the tire hole and shaft, we need the shaft and tire hole stick together and not move. So we need to force the shaft into the tire hole so that it is not moving while we move our products. That's it. That's all from us. Thank you.